Hello, today we'll be starting with types of chemical change or chemical reactions. There are four types of chemical changes. One is direct combination or synthesis, second one decomposition, third one displacement, fourth one double displacement or double decomposition. Now what is direct combination or synthesis? This is the reaction in which two or more substances combine together forming a single substance is called combination or synthesis. Let's say one reactant is A, another is B. We will get a compound called AB. Let's go through the examples. First is two elements react with each other to give a compound. What is the example? Carbon burns in oxygen to form a gaseous compound, carbon dioxide. This is an exothermic reaction. This is the symbol of heat. This triangle is the symbol of heat. And this S stands for solid, G stands for gas. So this all you have to write in the reaction, as well as you need to balance the reactions. Now let's say this one. This is iron reacts with sulfur to give iron sulfide or Fe2S, where balanced state of iron is 2 plus heat. This is also an exothermic reaction. Here heat is required to start the reaction, but once it started, it continues exothermally. Different salts also can be prepared by this reaction. By this type of reaction. Example, iron 3 chloride or ferric chloride. Iron 3 means the oxidation state or balance state of iron is +3. This is very important reaction which is again required in class 10. You can see iron is solid iron, through which when chlorine gas is passed, you will get iron chloride solid, salt. Then second category is element plus compound gives you a compound. Now here the compound is carbon monoxide, burns in presence of oxygen, which is an element, to form a single product which is carbon dioxide, and it is gaseous. Next is sulfur dioxide and oxygen combine to form sulfur trioxide. Then a third category is compound. When reacts with a compound gives you another compound. Like here, ammonia gas and hydrogen chloride gas react with each other to give the ammonium chloride solid. This is very familiar solid for you. This is a under sublimation you have gone through about this solid. Then quicklime or calcium oxide when combines with water gives you slaked lime or calcium hydroxide. There is a large amount of heat is generated, so the reaction is exothermic. Calcium hydroxide or slaked lime is produced. This calcium hydroxide or slaked lime is used for whitewashing. When it is applied on the wall, it reacts with carbon dioxide to give calcium carbonate and water. Now calcium carbonate is solid. This calcium carbonate is formed as a thin layer on the wall, which gives the shiny appearance on the wall. Other example is when carbon dioxide reacts with water in presence of sunlight as well as in presence of chlorophyll, gives you glucose and oxygen. This is the photosynthesis reaction. In the previous video also we had discussed about this reaction. There I had shown you a different equation, and then I have also mentioned that this equation can be written in two forms. You just refer that equation again. Now there are certain experiments you can do, like how to perform direct combination reaction. First case, if you take some black lead sulfide PBS in a test tube and then heated, a black sulfide reacts with oxygen to give you white colored lead sulfate. So this is the combination reaction. Second reaction, if you hold a piece of magnesium ribbon over a flame and it will burn with a dazzling white light in presence of oxygen to give you a ash color magnesium oxide powder. Next will come to decomposition. Now decomposition is the chemical reaction in which a compound splits into two or more simpler substances, maybe elements or compounds, and this reaction is called decomposition reaction. Now AB gives you C plus D plus E plus whatever. Now these products either may be elements or compounds, and these products do not recombine to form the original compound. The reactions may occur in presence of heat, light or electric current. Read this part very carefully that these products do not recombine, because in due course of time you will find there is a category of reaction where the products can recombine. So now this heat, light, electricity, these are different forms of energy. They cause the bond breaking in the molecules of reactants to yield simpler products. Now we will see about bonds in the next chapters of this class. Now compounds will give the elements. Orange color mercuric oxide, when heated, decomposes to form two elements. One is shiny mercury and oxygen. Now you know this delta sign or this triangular small triangle is representing heat. When silver chloride, which is white in color, is exposed to sunlight, it gives grey color silver and greenish yellow chlorine gas. Third is very common, which you have learned several times, that is water. When electricity is passed through water, it decomposes into hydrogen gas and oxygen gas. Next category is when compounds give elements and compounds. Like potassium nitrate, when heated, gives you potassium nitrite and oxygen. KNO2 is called potassium nitrite, NiTrite, and this is nitrate. There is a similar reaction with sodium nitrate. Sodium nitrate on heating gives sodium nitrite and oxygen. You can write that equation yourself. When calcium carbonate is heated at about 1000 degrees Celsius, it will give calcium oxide and carbon dioxide. You have to remember all the conditions of the reaction. Write, practice by writing so that you can remember the equations. Now ferrous sulfate, which is originally is called ferrous sulfate heptahydrate or FeSO4 7H2O. It is a green color crystal. On heating, this gives white color FeSO4, and this FeSO4 on heating gives brown color solid of Fe2O3, sulfur dioxide and sulfur trioxide. Due to the presence of this mixture of sulfur dioxide and sulfur trioxide, a suffocating and pungent smell of burning sulfur is obtained. So remember this equation. First a green crystal to white solid. White solid when heated gives you a brown solid, which is called ferric oxide. Fe2O3 is called ferric oxide. So these above reactions were carried out by heat. So a new term can come in our mind, which is called thermal decomposition. Thermal means application of heat. So a decomposition reaction that is brought about by heat without any recombination on cooling, that I have told you at the beginning of the decomposition reaction to remember that part. without any recombination on pooling is called thermal decomposition reactions. The thermal decomposition of metal compounds, here the decomposition of metal compounds by heat are based on their activity. There are 4 categories of metal compounds are shown in your syllabus, which we will discuss. Now there are compounds of, we will discuss about metal hydroxide, metal carbonates, metal bicarbonates and metal nitrates. Now first is your hydroxide. Just see this. Metals which are very reactive, their compounds are very stable to heat. They do not decompose easily. So these are potassium and sodium. Then comes calcium, magnesium, aluminium. They decompose on heating to form metal oxide and water vapor. Then comes zinc and calcium. Calcium is shown over here, they decompose. Zinc also same. They form oxides and water vapor. Then comes lead, copper. Iron also in the same category, they also give you this. Now if you go to mercury and silver, they give metal, oxygen and water vapor. So there are 3 groups. First group contains stable one, sodium, potassium. Second group which decomposes to oxides, those are calcium, magnesium, aluminium, zinc, iron, lead, copper. And third group, they give metal, oxygen and water vapor. Those are mercury and silver. Now come to the carbonates. Potassium and sodium again stable to heat and soluble in water. Second group, where you have calcium, magnesium and aluminium. They decompose on heating with decreasing vigor to form metal oxide and carbon dioxide. So there are the reactions, how these are formed. You can remember always, if there are carbonates and you are heating carbonates, you will definitely get carbon dioxide as one of the product. Third group is your similar to the previous one, mercury and silver. They are again decompose to form metal, oxygen and carbon dioxide. In case of hydroxide, the products were oxygen and water. Here carbonates, so one of the product is carbon dioxide. Third is metal bicarbonate or metal hydrogen carbonate. They decompose to give metal carbonates, water vapor and carbon dioxide. Last category is your nitrates. Here sodium and potassium nitrates already shown in one of the reaction. They decompose to give the metal nitrite and oxygen. Remember this spelling. There is another word called nitrite, which is N3 minus. So don't mix up these two. Then the second category, calcium, magnesium, aluminium, zinc, iron, lead, copper. So they decompose to form oxide, brown color, nitrogen oxide, dioxide gas and oxygen. And third category, these form metal, brown colored nitrogen dioxide gas and oxygen. Now some decomposition reactions are taking place in our body, one of which is digestion of food. The starch present in the food turns into glucose by the enzymes. Proteins also undergo decomposition to form amino acids. Fats and oils also decompose to produce fatty acids and finally oxidized by respiration into carbon dioxide and water and gives us the energy. So this is the example of decomposition reaction in our body. Now perform some decomposition reaction. If you take some lead nitrate crystals, which is white in color, in a test tube, it will first melt, and after further heating it will give reddish brown nitrogen dioxide gas, oxygen, and a yellow color lead monoxide in the test tube. These two gases will go up. Second reaction, if you take some zinc carbonate in a test tube fitted with a cork and the bent glass tube, heat the zinc carbonate, definitely you will be getting the carbon dioxide. Carbon dioxide turns lime water milky. Zinc oxide solid will be obtained, which is yellow when hot, white when cold. Next reaction is, if orange color ammonium dichromate is heated, it will give green color solid with the flashes of light, and there will be evolution of nitrogen gas and water vapor. Next is copper sulfate, blue color copper sulfate, or hydrated copper 2 sulfate, that is copper valency is 2 and hydrated means it contains 5 molecules of water. This is very common reaction which you already know, which when heated gives you white color copper sulfate and 5 molecules of water will be obtained. Now if you add this CuSO4 is also called anhydrous copper sulfate. If you add water in anhydrous copper sulfate, you will be again getting the blue color copper sulfate crystal or hydrated copper sulfate. Now this reaction is called reversible reaction. This reaction is also called the reversible reaction. I have shown by this one only. This is the reversible sign we had already discussed in the previous video in the preparation of ammonia. Now here this test is also used to detect water. This also we will be discussing in the chapter of water. And remember all these equations very properly, because these are again used in class 10. Now a new category of reactions has come in our mind now. This is reversible reaction. What is this? This is a group of reaction in which the direction of chemical change can be reversed by changing the conditions under which the reaction is taking place. Examples, other example, when steam is passed over red hot iron, the latter is partially converted into magnetic iron oxide and hydrogen is released. You have gone through this equation in hydrogen chapter in class 8. This year also you will go through. On the other hand, if hydrogen is passed over the heated oxide, that is magnetic oxide, it partially changes back to steam. In either case, the reaction ends with a mixture of reactants and products. Now, how to show the thermal dissociation reaction? This is called dissociation reaction. That's why I told you that in thermal decomposition there is no recombination, but in thermal dissociation there is recombination. Now ammonium chloride gives on heating ammonia and hydrogen chloride gas. These gases move at the upper part of the test tube, which is the cooler. Again there in the upper part of the test tube they form again the ammonium chloride, which appears as a white sublimate. So the simultaneous reversible decomposition reaction brought about only by heat is called thermal dissociation. So this is the definition of the thermal dissociation. There is many a times there is a question to differentiate between thermal dissociation and thermal decomposition. Another example of thermal dissociation is when dinitrogen tetroxide is heated, it will give reddish brown nitrogen dioxide gas, which when cooled it will give back the dinitrogen tetroxide. Then come for the displacement. Displacement is a chemical change in which a more active element displaces a less active element from its salt solution. AB plus C. C is the more active element replaces the B, which is the less active one, gives you AC plus B. How to show? Blue color copper sulfate is taken in a beaker. A few pieces of zinc is put in it and stirred with a glass rod. Blue color solution will generally fade on, gives us a colorless solution of zinc sulfate, and same time reddish brown particle of copper settle down in the beaker. Second case, in a test tube, dilute sulfuric acid is taken and drop a small piece of magnesium ribbon. A brisk effervescence takes place and hydrogen gas is evolved, which burns with a pop sound on bringing matchstick near the mouth of the test tube, and magnesium sulfate is formed. Third equation is, if chlorine gas is passed through a solution of potassium iodide which is colorless, the colorless solution will turn into yellowish brown due to the appearance of iodine. Here, chlorine is more active nonmetal, replacing iodine from potassium iodide to give potassium chloride and iodine. So, with the help of above examples, the activity series of elements is prepared. So, what is this activity series? You have to learn this activity series. Most active metal is placed on the top. The reactivity decreases downwards. Platinum is the least active metal. Similarly, for non-metals, fluorine, chlorine, bromine, iodine. Fluorine is the most active, iodine is the least active. So, the more reactive element displaces the less reactive element from its salt solution. So, potassium can displace any one of this, but gold cannot displace potassium, or mercury cannot displace potassium. Now, here hydrogen is taken in between as a reference material. Sorry. Now come to the last point, that is double decomposition. This is the type of chemical change in which two compounds in a solution react to form two new compounds by mutual exchange of radicals. This is also called double displacement reaction. I have shown you how you are getting it. AB plus CD gives you AD plus CD. You also practice this way, the way I have shown over here. Two types of double decomposition reactions are there. One is precipitation, another is neutralization. What is precipitation? A chemical reaction in which two compounds in their aqueous state react to form an insoluble salt, which is called a precipitate, as one of the products. Example, barium chloride reacts with sodium sulfate, gives you the precipitate of white barium sulfate and sodium chloride. I have shown how this reaction is taking place, the interchange of the radicals. Copper sulfate, when reacts with hydrogen sulfide gas, this gives copper sulfide, which is black color, and H2SO4. Now, precipitation is the formation of a solid which is insoluble either by mixing two solutions or by passing a gas into a solution. Both the examples are shown above. Now, how to show the double decomposition reactions? Take a solution of silver nitrate in a test tube, add dilute hydrochloric acid or sodium chloride solution, you will get the white curdy precipitate of silver chloride and corresponding either acid or sodium nitrate salt. That is, if you use hydrogen chloride, you will get nitric acid. If you use sodium chloride, you will get sodium nitrate. Next, barium chloride, when reacts with dilute sulfuric acid, you will get white color precipitate of barium sulfate and hydrogen chloride. Now, there may be certain cases when double decomposition reactions may also occur with evolution of gases. Some examples are given like iron sulfide, zinc sulfide. If they react with certain dilute acids, they will give hydrogen sulfide. This characteristics is it smells like rotten egg. Next is neutralization. This is the reaction between an acid and a base that forms salt and water only. This is very important one. If there is any other product by the reaction between these two, then that is not the neutralization reaction. This we will be getting elaborately in class 10. But the product will be salt and water only. Here NaOH is base or alkali. What is alkali? That will just know that alkali is a soluble base. Details will be gone through in class 10. This reacts with acid, it gives you salt and water. Now I have written it in ion form, Na plus OH minus plus H plus Cl minus. Then here product side Na plus Cl minus plus H plus OH minus. If I cancel the common ions, I'll get H plus OH minus to H2O. Next, now neutralization reaction can take place by the soluble base with alkali and insoluble base with alkali. I have just shown two examples here, potassium hydroxide and ammonium hydroxide. These are soluble bases or alkali. They react with acids to give the corresponding salts and water. You can write the same reaction with sodium hydroxide also. Instead of HNO3, you can take other acids also. Neutralization of insoluble base with acid. These are insoluble bases. They give you the corresponding salts on the basis of whatever acids are taken and water. Other hydroxides, these hydroxides are also insoluble bases. Then go for the applications of neutralization. Now if someone is stung by a bee, formic acid enters the skin and gives pain. So that can be relieved by rubbing the spot with a slaked lime or calcium hydroxide or baking soda, both of which are basic in nature. If in our stomach there is an excessive secretion of HCl and we experience pain, generally in case of ulcer etc., that can be relieved by milk of magnesia or solution of sodium hydrogen carbonate, which are basic in nature. If there is a deficiency of HCl, some or the other suitable organic acid can be taken in dilute form to make up for it. Next is, acid is accidentally spilled onto our clothes or body sometimes. It can be neutralized by ammonia solution, which is called ammonium hydroxides or NH4OH. Last is, if soil is some case acidic and unfavorable for growing certain crops, slaked lime is added to neutralize the excess acid. This is the end of the 2B. Thank you.